ARW-1962. In this video, we are going to look at a new instrument here at ARW-1962, and specifically, we will be looking at the Ultrasonic Thickness Gauge, ARW-1962. This is a thickness gauge in the specialized single probe category, which is specifically designed to offer extremely high precision measurement features for professional use. In fact, it is also referred to as a precision type of instrument, because it is fully capable of measuring even very thin thicknesses and with precise micrometer level resolution. The standard equipment for this specific instrument clearly includes the main body of the device, which also features a very solid and durable build. Additionally, it comes with a high-quality protective shell made of thick rubber. We have connection cables, serial cables with USB. Use the provided power adapter for the charging process. The instrument is equipped with internal rechargeable batteries that can be recharged as needed. We have an entirely empty gel container, which is carefully filled up at the time of sale. This package includes a USB flash drive that contains the essential software, which is the dedicated program used to download and manage your data. And here is the main component. The probe that comes as standard with this kit is a high-precision 15 MHz A-line probe equipped with a delay line. It is a single probe that allows you to accurately measure very thin thicknesses easily. As we know, ultrasonic thickness gauges are instruments that allow you to measure the thickness of a material without needing access to both sides from the opposite side, but simply by using a coupling gel and placing the probe on it. The single probe allows you to measure thicknesses that are exceptionally thin and delicate, from 0.5 to 0.5 millimeters, and potentially even thinner in some cases depending on the material, up to 20 to 25 millimeters, again depending on the material, with resolutions that can reach the micron level and measurement repeatability equal to 1 micron. Now we will examine these specific capabilities in a bit more detail. The features and functionalities of this thickness gauge. The first screen that appears when we turn it on is a scan screen, so a scanning mode where we have a graphical representation of the waveform and all the information is displayed directly on the screen. The measurement, the memory data, in this case A stands for A scan. Later we'll see that by changing the screen we'll also have a different view of the memory. The propagation velocity value, 5,920 for steel, is pre-configured by default in the system, as is the automatic gain. We will now examine some specific functions that need to be adjusted according to the waveform. So based on characteristics that go well beyond just simple thickness measurement, but also allow us to view other return echoes and in order to properly configure the instrument. Clearly, this process requires a higher level of specialized technical skills and professional knowledge. Right here in front of us, we have the probe, which is the standard issue probe typically supplied, the DTM-15. This is a 15 megahertz probe that works approximately from 0.5 up to 15 to 20 millimeters. And it is specifically designed to allow for very high measurement precision and consistent repeatability. This is a specialized single element probe equipped with a delay line. Probes that are used on instruments, also called precision instruments, precisely because they allow for detection with micro-level precision. The last indication we have is the battery indicator. The power supply uses rechargeable batteries. They are standard alkaline batteries, but they are special rechargeable batteries, not the regular batteries you find on the market. After that, we have the possibility, using the function keys, to navigate through the various screens. Then we will be able to observe that we have the digital B-scan. So here we have a wide variety of different display screens that we can view depending on the specific measurements we want to carry out and complete. And then we return to the scan. Now we are going to look at all of them, all the functions, menu. As we can see, here we have 100th resolution. We will see that later we will also set the higher micro resolution. The menu. The menu starts with the selection of the probe type. As we said, we have a TTM 15 megahertz. Here we have a whole series of different probe settings. Because this specific instrument can use both double probes, meaning double crystal, as commonly used in corrosion testing, and single probes of various frequencies, such as 10 MHz, depending on the material characteristics. By default, the standard supplied probe is the 15 MHz model, which covers 90%, if not even more, of the typical applications for this particular type of ultrasonic thickness gauge. Those who use this thickness gauge do so to measure very thin thicknesses with very high precision, so for sheet metal and other materials that may have different characteristics. For example, those who do molding or similar work need to be able to measure to the 100th of a millimeter and even split the 100th. This is the right instrument for that. After that, we have measure mode. Measure mode allows us to set the automatic measurement function, so pulse, echo, 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 thin and thin, echo, echo. Depending on the specific type of probe being used, in this case it is configured automatically by the system. This instrument, as I mentioned earlier, also has the option to use two different probes simultaneously, so it can also be configured to operate in pulse, echo, and interchangeable echo-echo modes. For convenience, it is always left on automatic so that the instrument recognizes the measurement mode. Digital mode. We will see this later with the screens. These are the ones we went through. In the digital function, we have the option to set the display to differential, maximum and minimum, average calculation, or simply thickness visualization. So, a series of specialized functions are used to define the visual graphical representation of the waveform in the B-scan. The waveform. For example, also the peak mode. The peak, meaning this allows us to view the peak, the presentation of the peak, either from the center or from the beginning. Let's say this is a more detailed technical consideration for those who use these instruments. Not only for standard material thickness measurement tasks, but also to thoroughly inspect for internal defects or to go and see them. If there are any internal imperfections in the material, there are settings that allow you to detect them. This always depends on the user's expertise. Otherwise, it can be used as a standard high-precision thickness gauge. A bit later on in the video, we will also look at other settings that are still part of the waveform representation. Standard thickness is the specific thickness that we manually configure. Then, for the calculation of the differential, we will look at the screens when we go to view them. Looking at the screen by screen, the low and high warning thresholds are the low and high alarms, which can be adjusted and set. So here we have 100 for the high and we have 0 for the low in order to have an audible and visual signal regarding the separation of these alarms. Next step here too, we have the waveform. Furthermore, this also specifically concerns the setting of what is known as the Biscano screen. So with 4 distinct and separate modes for displaying the waveform. That is, we can manually choose between the full negative radio frequency or positive display modes. These are the different display screens that we will have in the wide variety of settings of this graphical representation of the waveform. Moving on to the next available option, waveform trace. This too is consistently and directly related to the visual representation of the Viscan screen, specifically to the overall graphical representation. Now, let's talk about resolution. Here it is. This is actually one of the most important features of this tool, namely the impressive ability to also select a 1000th level resolution. Thanks to the specialized types with a single sum, which therefore possess a single crystal, the ultrasound's entry and exit paths are in a perfectly straight line. This unique configuration allows us to achieve a level of measurement precision and repeatability that is truly, as we will soon see together, truly astonishing. Next step, unit of measurement, millimeters, inches. The update frequency of the visual display for the ongoing measurement readings. Here we have the option to select 4, 8 or 16 Hz. 4 Hz is the standard default setting. Right now, we have the standard configuration. We can perform adjustments and changes directly. But when we turn on the instrument for the first time, this is the setting we will find. Clearly, if we set it to 8 or 16 Hz, the display will update much faster during measurement, so we will see significantly greater fluctuation in the readings. By setting the value to 4 Hz, we keep the measurement update a bit slower and much more stable. English. Here we only have the option to set English. We do not have the possibility to select other European languages. Auto power off. And manual. In this case, we have the option to set the auto shut off at 2, 5, 10, or 20 minutes. Or leave it on manual, which is the default setting. The depth setting is the measurement range. In this case, it is set to 24 millimeters. With this probe, we definitely won't go beyond 15 to 20 millimeters in steel, so we don't. Generally, unless you use double probes, these values should never be set very high. These instruments are designed for measuring generally very thin thicknesses. Gain mode, auto, this is also the gain setting. Here we'll see that there are some settings, including the gain, which should generally always be left on automatic, unless someone has a high level of specialized expertise in the technical fields of defect inspection and ultrasonics, in order to properly set what is commonly called the gate, as well as various functionalities that we will see later, such as the blanking and the peak detection, the visualization, to get a better indication of what might be happening. Perhaps an issue such as surface corrosion or a hidden internal defect located within the structure of the material, among which is the adjustment of the gain control. The buzzer is the acoustic signal. We can enable or disable it. Power save is the option to have an energy saving mode set to 120 seconds. This does not turn off the display. We have settings of 60 seconds or 120 seconds or off. It does not turn off the instrument, but rather lowers the screen illumination, providing energy savings for the device. Pack correct WPAC. This is a feature that works only with probes. Double probes, crystal probes. Double. Why? Because the specialized double crystal probe has 2 distinct half-moon shapes. The ultrasound starts from one side and returns from the other, creating an angle. This V-path here effectively corrects the specific problem that arises with that double probe system. Another feature still related to the representation of the discontinuity. Consequently, this allows for the specific ability to set a customized display mode for the female form within the system. The optimized setting is currently set to off. Now, this is an exceptionally useful and interesting feature because it allows you to fully optimize the reading process. That is, it helps to create a much more consistent and stable reading experience, so you can have perhaps even greater accuracy in the visual display. Generally speaking, this should be set to on to further refine the reading quality. Another feature, still regarding the graphical representation of the data, is the specific parameter known as energy. This value is set by default to 100 volts. It is a parameter that indicates the intensity of the energy. It is a default parameter that should not be changed. It must be left at 100 volts, so you should not make any changes to this parameter, otherwise it will affect the reading. It should not be modified. We have the date and time here as well. You just need to enter, move around, and adjust the parameters to set the values. The same goes for the time. Here we have it. The version, so the version of the MCU, the processor, and the version of the instrument software, which allows us to review the specific parameters regarding the configuration of this particular version. The last function in the menu is reset. The reset function provides a way for us to completely reset and return the instrument's parameters to their original factory settings. We will see that if we change certain parameters, it is important to use this function to restore the instrument. Now let's exit out of the menu and explore the different display screens of the instrument. As we mentioned, the main screen is the A-scan screen, which is the graphical representation of the waveform. Here we have function keys F1 and F2, plus the central button, which, in addition to entering the menu, also allows for saving options. Right now we have set it to manual, but we will see that it is also possible to set it to automatic. B-scan. Here we switch between screens. This is the option button. This button right here is the one that allows us to adjust and modify the gate, that is, the window, as well as the range, always referring back to the waveform and the delay. Now this is a parameter that is set according to the type of probe being used. If we change this parameter here, we also change the responses of the instrument, so it needs to be reset accordingly. If you happen to accidentally modify or change the specific value, you can simply navigate your way to the reset menu and restore all the factory default settings back to their original state. And these parameters will be restored. Both blank and blank are also configuration parameters that allow you to, by the way, you can also see them, these two parameters right here. The blue one shown as these two bars and the other one in red. I can change them, either increasing or decreasing them, which makes it so that these tools allow you to effectively eliminate risks. When detecting a specific material thickness where there may be a hidden imperfection or some surface corrosion, they help to significantly limit the issues caused by these situations. Of course, it is essential to have the skill and expertise required to use these ultrasonic instruments, to look for effects, and not just for displaying the thickness. Now, returning to the main screen, let's revert back to the normal display. Now we can go and examine some of the other scans. We can go to the B-scan. The B-scan is a specialized feature. Now we'll perform the test. A comprehensive feature that allows us to scan a specific path. That is to say, if we want to see the precise variation in thickness that we have, perhaps on the ring, along that entire path, we enable what is known as the B-scan. To begin, we simply press the center button and start with the process, the visualization. As we can clearly see on the screen right now, there is a detailed graph being displayed. Currently, we are moving and perhaps shifting to a lower level in the data so that we do not end up with, quite clearly, just a simple stepped sample. Once we finish completing the scan, we can lock it into place. If we hold down the button, not just pressing it briefly, but holding it for a longer time, we can save all of the data to memory. We can see that the memory capacity increases. So the specific memory in the scan was A, while the memory in the B scan is B. Then, as we'll see, if we transition over to the next screen, we will find F. This particular screen that you see here is the one that within the main menu allowed us to choose between several different available functions, such as the differential, the maximum, and the minimum. We can clearly see that we are able to set this specific function directly by using the navigation arrows. We also previously saw the standard default setting of 20 millimeters, which provides the standard visual representation. This is basically the primary function that allows us to view and analyze the differential in detail. Here we are measuring a standard 10 millimeters, we set 20 millimeters, 10 millimeters. If we go to 5 millimeters, we will see that the differential will be 15 millimeters. Then we have, as we said before, this is just the measurement, so we only have the clear measurement indication with a very wide GBA as well. We're talking about a large 20 millimeter digit for easy reading. Next, we have the maximum and minimum functions. Here, with this specific function, all we do is view the minimum value. If we go to the maximum setting, it always keeps the data according to the various readings we take during the process. If we go to higher values, it updates the display for us. Now, of course, it has reset itself to a value of 0.198 because the act of lifting up the probe and the gel has inadvertently created a distortion in the measurement. Next, we essentially have the distinct opportunity to take a series of multiple data readings with averaging. We go down with the arrow and move to the second one. What exactly do we have right here? It looks like we have 5 distinct readings to check. Now, let's go ahead and move down to a much lower value for our next step. Once we have completed the 5 readings, the instrument gives us the average of the readings directly. This feature is the last screen we have as far as the digital function is concerned. By pressing again, we return to Ascana. These are the screens. As for the explanation of the features and functions available on the ARW-1962 Ultrasonic Thickness Gauge by ARW-1962, we've covered everything. For further information, please refer to the end credits shown in the video or in the video description itself. Thank you for your attention and see you next time.